Good evening, everyone. Today's session is on KNN algorithm. Let us see how this algorithm works and how we basically classify the different data points using KNN. So, first of all, starting with the first part, what do you mean by KNN? KNN means K is the factor and nn is the nearest neighbor. So k is the value which is basically we find out the nearest neighbors out of it, right? And this is a very simple and easy to use algorithm, but a very powerful classification technique. Like whenever we use any classification technique for segregating our data points, right, we might be using classification, binary classification, and if we have multiple classes, we might be using multi-level or multi-class classification. But the only thing is how to classify it, right? Like suppose I am going to use like a classification technique for finding the mail is spam or not a spam mail, or like my output variable would be like pass or fail. So you classify your data, right, into number of classes, right? The output variable could be pass or fail, right? So here we have two classes, or you may say like when we specify a gender, it could be a male, female. So again, variable, the output variable is category, categorical data, right? So or you may say like your we may take a crop, types of crops, or you may say any classification you may take it when the output variable would be a class categorical type of data. You may use knn for regression problem set also, but mostly it is widely used as a classification algorithm, right? So let us see how it works. Classifies based on similarity measure. So whenever we have similarity among the data points, we may classify into like this particular point based on the pattern. This data point is falling under this group or classifying under this group, and the other point is classifying a next group, right? It is again non-parametric. Yeah, next is very important point. It is a lazy learning algorithm where does not learn until the test example is given. So, like we need to take an example for making the for making the machine to learn. Whenever we have a new data to classify, we find its k nearest neighbors from the training data, right? From the training data. So before moving into the detail, I will be telling you some of the data set part also. Like whenever we have a data set, right, it is divided into two parts. The first is training data, through which we going to train the machine, train the model, and testing data through which we are going to test the model. We are going to evaluate the model, whether it gives the accuracy, whether it gives a good factor, good F1 score or not. So if it is giving you a good F1 score, obviously it is a good algorithm, right? Otherwise, a good algorithm in terms of it is going to have your output that is a perfect fit into the model. Might be possible like we are you going to use the data set which is not actually giving the accurate results. So it could be based on the algorithm, or it could be the data set which you have taken, you have used which method for training the system, right? Now let us move to the next part. KNN classification approach, classified by majority votes, right, for its neighbor classes. Assigned to the most common class amongst k nearest neighbors by measuring distance between data. So what we do is we find out the distance between data. So this would be my suppose class, and we are finding the common classes, the common features out of it. So that the most distant like which has the minimum distance, we might be using Euclidean or Minkowski method for calculating the distance. So let's say an example, we have different data points. So we classify into blue and red dots, right? Over here. Let us see how the algorithm works. Step 1, determine the parameter k. So the number of nearest neighbors. So k would be your hyperparameter based on which you are going to apply the algorithm. So first factor is you determine the parameter k, which is basically what? Which is basically a number of nearest neighbors, right? Then in step 2, what we do is calculate the distance between the query distance and all the training examples, right? Sort the distances and determine nearest neighbors based on kth minimum distance. Now you calculate the distance with the help of any distance algorithm. Then gather the category Y of the nearest neighbors. Right, and the last step, use simple majority of category of nearest neighbors as the prediction value of the query instance. So let us take one example. Here your k value is 4 and you have 3 classes. Over here we have unknown class and we segregate it like this is my unknown class. We segregate is like it is not falling under this, it is not falling under this data point, it is not nearest to this, it is not following the patterns of this as well. So whereas these data points form a like it is giving all the class B is giving these data set and class A are giving these data points, right? Let us see how to find the distance, how we classify the data. So here we will be using Euclidean distance matrix, right? It is like we have used it for 19 pairs, right? Which is starting from here. So we have the first point, we are calculating the distance and how we are going to find out the distance. Let us see that also. There are different algorithms for finding the distance. So Voronoi diagram would be like this, describes the areas that are nearest to any given point, right? And given a set of data, right? Each line segment is equidistant between 2 points of opposite classes. Okay, so over here what we have is we have different data points, right? We have different data points. So you may see there are different data points which are like this. So here what we have seen describes the area that are nearest to any given point. Now what are the nearest data points, which are basically we take any data point and then we find the nearest data point from the set of data points. Each line segment is equidistant between two points of opposite classes, right? So that would be like you are making any these lines like this. These lines are like this. So we make like this, we make a equidistance between two points of opposite classes, right? Then we have decision boundaries. What are decision boundaries? Basically, it segregates the points into different things like with large number of examples and possible noise in the labels, the decision boundary can become nasty. Overfitting problem. You are collecting all the points. Might be possible there are some noisy points, noisy in the labels too, or there could be any outlier, right? Let us see how it works. Effect of k. So k, we know that the number of nearest neighbors. Larger k produces smoother boundary effect. Always remember, larger k gives you a smoother boundary effect. Route like this. Here, when k is equal to n, always predict the majority class. So here we have k is equal to 1. That means they are segregating they are classifying the data points. But when we have k, the larger value of k will be producing smoother boundaries effect, right? So always remember this thing, it is going to give you the smoother boundary effects in case of when the K value is larger. Then we have, let us see one diagram also. I told you whenever we train the data, there could be training error, there could be testing errors as well. So we try to minimize both the errors, right? So here we have the testing error when we have the K as 20 and when the K is 1. So model complexity would be more in that case. Let us see what are the pros and cons of this algorithm. So, and then we will be learning about like how to find out the distance between data points, right? So the pros, the advantages of this algorithm would be learning and implementation is extremely simple and intuitive, flexible decision boundaries, right? Cons would be your first thing, irrelevant or correlated features have high impact and must be eliminated, right? Typically difficult to handle high dimensional. Now when your dimensions are too high, it is very difficult to handle it, right? Then computational cost, memory and classification time computation, memory and classification time computation, right? So these are our advantages and these are our disadvantages of this algorithm. Now let us see some similarity and dissimilarity. If we talk about similarity, numerical measure of how alike two data points, two objects are, is higher when objects are more alike, right? Often falls in the range of 0 to 1. So the interval or the range between them is, it is falling between 0 to 1 in similarity case. And in dissimilarity, numerical measure of how different are two data points, how similar are two data points, how different are two data points. So this would be our similarity and this would be our dissimilarity. So when we have how two data points are similar, we have the similarity part and it's falling between 0 to 1 and is higher. Again, if it is lower, it is dissimilar, right? Lower when objects are more alike, right? So here what we have, numerical measure of how different are two data objects, lower when objects are more alike, it would be more different, right? Minimum dissimilarity is often to 0. Upper limit varies. So you might be having like it is the range and similarity is falling between 0 to 1. Here we have varies in the upper limit. Proximity refers to a similarity or dissimilarity, right? Now let us talk about Euclidean distance. How we actually calculate the distance between the data points. So the what is the formula? Your main point K point minus uh, the data point which you are where basically you are finding out. Like suppose I'm taking this as my K point and you are finding these two points as your nearest point, and then you find out the distance. So taking this point as K and applying the formula with another data point. So here over here we can have like your a one point and the other point, right? Whole square, okay, where p is the number of dimensions, right? You have the sigma attributes and ak and bk are respectively the kth attributes components or data objects a and b, right? Standardization is necessary if scales differ. So yes, if scales are different, so standardization is very important feature. Let us take how we calculate the distance. So here we have 2 points. First of all, let us take for p uh, p1. So x is 0 and y is 2. So x is, this is my x and this would be my y. X is 0, and y is 2. So here we have P1, P2, x is 2 and y is 0. So this would be my P2. Then P3, 3, x is 3 and y is 1. Right, then P4, x is 5 and y is 1. Right, so here what we have is we have different points, we have plotted those points. Now let us find out the distance, right? So obviously when you measure the distance from that point only, P1 to P1, it would be 0, right? And again the same thing, P2 to P2, it would be 0. So we will if we are subtracting it and making the square out of it, it is going to give us the 0 value. So P3 to P3 also, it is going to give you 0. Then P4 to P4, it is also going to give you 0, right? So you have find out mostly for 0 0 elements, for 0 value you have find out if you are uh, comparing the distance with other points. Now let us have the distance from other points, two different points. So this would be my P1 and this would be my P2. So you measure the distance, then P1 and P3. So you have to calculate the distance for every point, right? And applying this formula, that is this one, right? So here we have calculated all the distances, and then we segregate, like these points are basically these are the patterns which they follow, like 2.828, again 2.828, then 1.414, 3.16162, 5.099, 3.162, and 2, right? Then we have mid-Kioski distance. Now, mid-Kioski distance is the generalization of Euclidean distance method only. So, over here we basically take the absolute value, right? So, we can have where R is the parameter, P is the number of dimensions or attributes, AK and BK are respectively, and Kth attributes or data objects, and AB. So, you have two data points over here, right? And then we take the K as 1 to P, right? Number of points. So P is the number of dimensions. Number of dimensions, you may say dimensions or number of attributes, right? Now let us take one example. R is equal to 1. Mantan taxi cab L1 dog distance, a common example, that is of Deming distance, which is just number of bits that are different between two binary vectors. You have R value, Euclidean distance is 2 and R tends to infinity. So your L max norm, L infinity norm distance. This is the maximum difference between any component of the vectors, right? Do not confuse R with P. Always remember this thing. R is my you are taking any vector, and P would be my, what is P? P is the number of dimensions, right? Or attributes. So P, that is all the distance, are defined for all the number of dimensions. Now let us see cosine similarity. If D1 and D2 are two document vectors, so we find out the uh, cosine of D1 comma D2. So let us find the cosine of document vector 1 and 2. So over here we have two let us take one example, document 1 and document 2. So here we have 3, 1. So what we do is 3 into 1 plus 2 into 0 plus 0 into 0 plus 5 into 0. So this is how it is going to calculate. And later on, what we do is we just calculate it. We just add it. Right. And for absolute of D1, just take the multiply the same thing with the number of times. So here it would be 3 into 3, then plus 2 into 2, plus 0 into 0, plus 5 into 5, plus 0 into 0, and so on. So you will be getting this number 6.481. Then we have your next document vector, that is 1. So 1 into 1 plus 0 into 0. So this is my document vector 2, right? Document vector 2. And then you put the cosine of d1 and d2. Whatever you get, that will be your point, that is 0.3150, right? 1 exactly the same, 0 orthogonal, and minus 1 exactly opposite. So whatever you get it from cosine d1 and d2, you have these are the three different scenarios which you can check it out. So 1 is exactly the same point, same thing. 0 means orthogonal, and minus 1 exactly opposite. Now let us understand feature scaling as well. Standardize the range of independent variables, features of data, that is normalization or standardization. Now how we use normalization, standardization, or z-score normalization. So z-score, we basically take it as x minus mean upon standard deviation. So mu is your mean and sigma is your standard deviation. So what is the normalization formula? Your z-score formula. That are same. Rescale the data so that mean is 0 and the standard deviation from the mean standard scores is 1. So your mu is mean and your sigma is standard deviation from the mean. Now let us move to the next part, minimum and maximum scaling. Scale the data to a fixed range, and that range between, we know that the range is between 0 to 1, 0 and 1, and how to find out the maximum range, x minus x minimum and x maximum minus x minimum. So you take the difference between both of them and then you normalize it, right? Now let us see how efficient is it, efficient implementation. Consider data as a matrix or a vector. Vectors or vector computation is much more efficient than you computing with loop. So rather than using computation, you may use uh, looping concept, right? Can we use KNN for regression problems? Yes, why not? But only the thing is, mostly it is widely used. It is meant for classification problem only. But yes, it can be used. But when we say it is, when this algorithm is more efficient, it is more efficiently works with classification problem data set, right? So always, like whenever you use the this thing, let me come to the first point. Yeah, so always whenever you use this classification algorithm, you use it for basically you use it for classification problem. When you have data types and data points and you want to classify them, you can use any of the distance method. It could be possible, like you might be using Euclidean distance method, or you can use Minkowski distance method. Mantham method is also, you can use it. Overfitting problem. Now let me tell you one thing. I have trained the system with my training data set, right? Again, I am using this training data set for testing the data, testing the model. So obviously it is going to give you the problem of overfitting, right? It is going to give you the problem of overfitting, right? So always remember this thing whenever we use this thing. Overfitting means when you are taking that part, but you are not going to use the, it is not recommended to use the training data for testing the model. Always try to have a data set and segregate into two groups, training data set and testing data set. Maintain the ratio, that is 80 to 20, right? 80 to 20. So over here, like what you can do is, if you are maintaining the ratio, you can have it. Okay, so I hope you have understood like what we have done in KNN and how it works, right? So hope you have understood the session and hope you like the session. Thank you.